Hello everyone, this is our summary of functions. So there are two key concepts here, injective and surjective. An injective has a nice yellow border, surjective has a nice blue border, and when you combine yellow and blue you get green, which is bijective. A bijective function is both injective and surjective. Okay, so for each of these, there's like a formal definition, there's an example with the bubble diagrams, and then there's an example with a graph of a function. So the definition of injective is, if f of a is equal to f of b, then a must equal b. Best seen by an example here, or in fact, actually what is not injective. Okay, so in this instance here, this value is the f of a and it's equal to the f of b because it's equal to itself, but a is not equal to b. Therefore, this function here is not injective, okay? Whereas the function above here, top left, is injective because there's only one arrow coming into each point there in the image, okay? So it's one-to-one means, like as it says, for every one value here in the domain, there is one value in the range. Now, in terms of the graph of the function, f of x is injective if it passes the horizontal line test. And that means any horizontal line intersects the graph of the function at most once. So you can see here, e to the x is injective. Any horizontal line intersects the graph at most once. Okay, horizontal lines don't need to intersect the graph, so there are many of them that won't intersect the graph at all, but if they do, they intersect the graph at most once. Whereas y equals x squared over there is not injective because there are an infinite number of horizontal lines that will intersect the graph twice, and that means it's not injective. And just to bring that back to the definition, take for example here, under the function y equals x squared, 2 will get mapped to 4, minus 2 also gets mapped to 4. So if we call this f of x, then the f of 2 is equal to 4, which is equal to the f of minus 2, but 2 is not equal to minus 2. So it's like in the previous picture bubble diagram, we have the value 2 in the domain, the value minus 2 in the domain, and they are both getting mapped to 4 over here in the range, and that can't happen for an injective function. Okay, so you have the definition, you have the bubble diagram, understanding it, and what it means for the graph of a function. Now, moving on to surjective. The other term for describing surjective is onto, which makes sense now, hopefully, when I describe what it is. So if f is mapping from a to b, a is known as the domain. They're all possible inputs, all possible x values. B is the codomain, all possible outputs, all possible y values. And f is surjective or onto if the codomain is equal to the range. Now, the range of f is all the outputs of the function. So best seen again by an example here. So in this example here, the domain is A, B, C, and D, okay? The codomain are all possible outcomes, which are all the values there in that set, D, E, and G. And the range are all the values that have arrows coming into it. So f of A is equal to D, so D is in the range. F of C is equal to E, E is in the range. And in this instance here, the codomain, you can tell there the two sets are equal to each other. So a codomain is equal to the range, therefore the function is onto. And as before, sometimes it's easier to understand the concept by seeing what is not onto. So in this instance here, our domain is ABC. Our codomain is this whole set, D, E, G, H, and our range are all the values that are f of something. So it is D is the f of A, E is the f of C, and G is the f of B. That is the range, and since the range is not equal to the codomain, therefore the function is not onto. So that's what it means in terms of the bubble diagrams. And then to come to a graph. So in order to figure out if a function is surjective or onto, you really need to know the codomain, like you have to be told this set over here, okay? You also need to know the function, and from there you can determine its range. But if you're not told the codomain, you can't determine whether it is surjective or not because it's part of the definition, codomain equals range. So for the function f of x equals sine x, we know that the range, all possible y values along this curve, all the outputs of sine x, range between minus 1 and 1, okay? So the range is y greater than or equal to minus 1, less than or equal to 1. And the codomain is also that. These are all values between minus 1 and 1. So therefore f is surjective or onto. And let's see what is not onto in terms of a graph. So f mapping from OR into OR. There is our codomain there in the yellow box, OR. F of x equals x squared, our example from below. The range of f, so what the range of f are all possible y values, all the outputs. So all the y values along that curve are y values that are greater than or equal to 0. So the range is all positive real numbers, including 0. The codomain is all real numbers, and since the codomain is not equal to the range, f is not onto. Okay, so for surjectivity, you need to figure out what the range of the function is. You need to be told what the codomain is, that you're just told that. You can't figure that out yourself. That is determined in advance. And then if the two are equal to each other, it's surjective. If not, it is not. And if a function is both injective and surjective, then the function is said to be bijective. And bijective, if a function is bijective, that means the inverse exists. I'm just going to give you a little few pictures of bubble diagrams here. So, for example, bijective would be something in which, there we are. For every value in the domain, there is a value in the codomain, a one-to-one value in the codomain, and sorry, this is a little slow, but we're getting there. So it'll have to be one-to-one to begin with, okay? And then every value in the codomain has to be hit. Okay, this can get mapped over to there. So if a function f is mapping from there across to there, then the inverse, f inverse, takes these values back to where they came from. Okay, so to give you a slightly better bubble diagram there, if you have A, B, and C getting mapped under the function to D, E, and G. Okay, so the f of A is equal to D, f is mapping from there to there, the f of B is equal to E, and the f of C is equal to G. Then f inverse will take G back to C. It'll take E back to B and D back to A. So f inverse of D is equal to A. The f of B is equal to E, and the f of C is equal to G. Then f inverse of E is equal to B, and f inverse of G is equal to C. And when you compose the two, f after the f inverse of A, for example, so that takes a f inverse, of D, that should be. So f inverse of D will take D back to A, f of A takes A to D. So you should end up back where you started. So you work from the inside out when you're evaluating these. The f inverse of D is A, and then the f of A is equal to D. And this is true in general for an inverse. F of f inverse of x is equal to x, and also f inverse of f of x is equal to x. Okay, and just a quick one about how to find the inverse function. So if you're given y equals f of x, and we get the inverse, y equals f inverse of x, by following the following steps. So write x in terms of y, and then swap x and y. So an example here, if f of x is 2x plus 7, and then you can say y is 2x plus 7. Write x in terms of y, so 2x is y minus 7, x is a half of y minus 7, and then you swap x and y. Okay, so this y becomes an x, this x becomes a y, and this here is your inverse function. And just a note, you could swap those steps. You can actually swap x and y first, and then you write y in terms of x. So if you've seen it that way, that's perfectly fine. Here's your check. F inverse after f of x is x. So working from the inside out, f of x is 2x plus 7. F inverse of 2x plus 7, so you go to your inverse function, and wherever you see x, you put in 2x plus 7. So that'll be 1/2 times 2x plus 7 minus 7, and that is indeed x. And then one final point about the graph of an inverse. To get the graph of f inverse, you reflect the graph of the function in the line y equals x. So that's the line through 0, 0 with slope 1. So you see here below, I have in green the function e to the x. Its inverse is the function ln x. This is f inverse of x. And to get the graph of ln x, you can reflect the function e to the x, that green one, in the line y equals x. And how do you reflect in a line. So you take a point on the curve, you go to the line at a right angle. Let me do this with a darker color. Go to the line at a right angle and go the same distance the opposite side at a right angle. That is how you reflect. So go to the line of reflection at a right angle, go the same distance the opposite side. Mine isn't exact, but you get the idea. Okay.